Next effect is the effect of pressure by changing volume. It is only involved system with gaseous components. Why only gaseous components? Because liquids and solids are nearly incompressible. So the pressure change can occur in three ways. The first one is by changing concentration of a gaseous component. The second one is by adding inert gas. And the third is by changing the volume of the reaction vessel. Okay, now look at the first case. Decrease the volume or increase the pressure. So if the volume of the system is decreased, the pressure of the system is increased. This refers to the Boyle's law, where the volume is inversely proportional to pressure. So the equilibrium will re-establish to decrease the pressure of the system, because the pressure is increased. The disturbance is the increasing in pressure. So the system will decrease the pressure. Next, the equilibrium position will shift to the side with less number of moles of reacting species, which is gas. It is because less number of mole of reacting species will exert lower pressure. Thus, the pressure of the system can be decreased. Okay. Now, the second case, if we increase the volume or decrease the pressure. So, if the volume of system is increased, so the pressure of system will be decreased. So, the pressure is decreased. So, the equilibrium will re-establish to increase the pressure of the system. So, how? The equilibrium positions will shift to the side with more number of mole of reacting species. This is because more number of mole of reacting species will exert higher pressure. Thus, the pressure of the system can be increased. Okay, changes in pressure. So, based on the following reaction, predict the position of equilibrium when 1 mole of PCl3 plus 1 mole of Cl2. So, it becomes 2 mole gas on the left hand side. Produce 1 mole of PCl5 gas. So, 1 mole gas on the right hand side. So, based on the following reaction, predict the position of equilibrium when the volume of the container is decreased. So, according to Boyle's law, we know that volume is inversely proportional to the pressure. So, when the volume is decreased, means the pressure will be increased. So, the increased pressure is the disturbance in this system. So, the system will reduce the disturbance. How? By reduce the pressure. So, how the system wants to reduce the pressure? So, it will shift to the side with less number of mole. So, which one is the less number of mole? Right hand side. So, the system will shift to the right. Okay. Now, the second one is when the volume of the container is increased. So, when volume increase, the pressure is decreased. So, decreased pressure is the disturbance. So, the system will increase back the pressure. So, how to increase back the pressure? The system will shift to the side with more number of mole. So, if more number of mole, so of course the system will shift to the left. Based on the following reaction, predict and explain the direction of the equilibrium when 1 mole of H2O gas plus 1 mole of carbon solid produce 1 mole of carbon monoxide gas, CO gas, plus 1 mole of H2 gas. Okay, because of the carbon solid is remain constant, so we only consider 1 mole of H2O gas on the left hand side, while we have 2 mole of gas on the right hand side. Okay, now comes the disturbance. So when the volume of the container is decreased, so according to Boyle's law, when the volume is decreased, the pressure will be increased. So the equilibrium will re-establish to decrease back the pressure, because the increased pressure is the disturbance. So how to decrease the pressure? So the system will shift to the less number of mole. So if less number of mole, the system will shift to the left. Okay, the second disturbance, when we decrease the pressure. So if pressure decrease, the volume will be increased. So the equilibrium will re-establish to increase the pressure by forming more number of mole. So if more number of mole, so it will shift to the right. Based on the following reaction, predict and explain the direction of the equilibrium when 2 mole of HI produce 1 mole of H2 plus 1 mole of I2. So we can see that we have 2 mole gas on the left hand side and also 2 mole gas on the right hand side. Okay, so what will happen to the equilibrium when the volume of the container is decreased? So we knew that when the volume is decreased, the pressure will be increased. So what happened to the equilibrium? In this case, no change to equilibrium. Okay, why? Because there are same number of mole. So we can see 2 mole on the left hand side and also 2 mole on the right hand side. So if there are same number of mole, means no change to equilibrium even though the pressure is increased. So the volume change will have no effect on the equilibrium. Okay, so the second one is when we decrease the pressure. Okay, the pressure is decreased. So what happened to the equilibrium? No change to equilibrium. Why? Because there are same number of mole on both sides. So if same number of mole on both sides of the chemical equation, means there will be no effect on the equilibrium. Okay, keep in mind. Okay, so if we increase the pressure or decrease the volume, actually this is the same thing. When the pressure increase, the volume will be decreased. So it will shift to the side with less number of mole. Okay, so if we decrease the pressure or increase the volume, so the pressure decrease, the volume will increase. So the system will shift to the side with most number of mole. Exercises. So based on the following reaction, predict the direction of the equilibrium when 3 mole of H2 plus 1 mole of N2 produce 2 mole of NH3. So please answer this question in order to achieve learning outcome in this subtopic.